Solar and wind power are growing rapidly, but they face a major challenge: they are intermittent. When the wind stops blowing or the sun goes down, we still need electricity. Today, we are exploring Enhanced Geothermal Systems, or EGS, a technology that drills miles underground to mine Earth's heat, providing clean power that runs 24 hours a day, anywhere on Earth. A modern city never sleeps. Hospitals, water treatment plants, and servers require constant power, called baseload. Historically, we have relied on fossil fuels like coal and gas for this continuous supply. While wind and solar are clean, they are intermittent. To fully eliminate fossil fuels, we need a clean, steady source of baseload energy. Conventional geothermal plants are great, but they are limited. They require a rare combination of shallow heat, underground water, and porous rocks, which restrict them to volcanic regions like Iceland. Enhanced Geothermal Systems, or EGS, bypass this constraint by drilling deep into dry granite rock, injecting water, and engineering a custom reservoir anywhere. The science behind EGS is like pouring water on a hot frying pan. Engineers drill 2 deep wells miles underground where temperatures exceed 200 degrees Celsius. They pump cold water down the first well, force it through cracked hot rocks to absorb heat, and pull the boiling steam up the second well to run electrical generators. Creating an EGS reservoir requires 3 main steps. First, engineers drill miles down into hot granite rock. Second, they pump high-pressure water down the well to fracture the rock, creating a web of tiny pathways. Finally, they connect a second well to complete a closed loop, circulating water continuously to generate power. How does water flow through solid granite? The key is hydraulic fracturing. By pumping pressurized water down the well, engineers force open tiny pre-existing joints in the granite. These cracks are less than a millimeter wide, but they create a massive subterranean radiator, letting injected water contact miles of hot rock. EGS operates as a closed-loop system. The steam that spins the turbine is cooled back into liquid water and immediately pumped back down the injection well. This ensures zero water is lost to evaporation and prevents any chemicals from escaping, protecting underground drinking water aquifers. EGS is capital-intensive because drilling deep wells is expensive. Currently, it costs around 8 cents per kilowatt-hour, making it slightly more expensive than gas. However, because geothermal fuel is completely free and the plants run constantly, target costs are projected to fall to 4.5 cents by 2035. A primary concern with EGS is seismicity. Forcing pressurized water into rocks can cause them to slip, creating micro-earthquakes. While most of these are too small for humans to feel, engineers use sensitive seismic monitoring systems that automatically adjust pump pressures to prevent any damage on the surface. EGS is rapidly advancing. A startup called Fervo Energy recently built a commercial pilot plant in Nevada that generates 3.5 megawatts, supplying power directly to Google's data centers. By borrowing drilling techniques from the oil and gas industry, they cut drilling times and costs dramatically. EGS is the missing piece of the clean energy puzzle. Because it can dial power output up or down, it can step in when solar drops off, acting as a clean geologic battery. Best of all, geothermal plants have a tiny land footprint, ensuring we can power our cities without consuming vast tracts of natural land. Enhanced geothermal systems turn the earth beneath our feet into a clean, infinite power plant. By drilling deep to mine Earth's core heat, we can secure clean baseload electricity 24 hours a day, anywhere. What do you think about EGS? Let us know in the comments below. If you want more simple science explanations, subscribe to Layman's Field, bringing knowledge for everyone. We will see you in the next video.